Lesson 10.2, Polygons and Quadrilaterals. A polygon is a closed plane figure whose sides are segments that intersect only at their endpoints. A regular polygon is all sides have the same length and all angles have the same measure. A convex polygon is if a segment joining any two interior points lies completely within the polygon. A concave polygon is if a segment joining any two interior points does not lie completely within the polygon. A diagonal of a polygon is a segment that joins two non-adjacent, and adjacent means next to each other, so they're not next to each other, vertices. Let's look at some examples of those definitions. Here are some polygons. You can see they're polygons because the definition of a polygon is a closed figure whose sides are segments that intersect only at their endpoints. The endpoints, you can see they're only intersecting at the endpoints. And it's closed, there's no openings to the polygon. Let's look at what's not a polygon. You see this one intersects in the middle here, so it's not intersecting at just the endpoints. This one is not a line segment. Anytime there's like some sort of curve, it's not a polygon. That's why a circle is not a polygon. This one, see how it's open right here? It's not closed, it's not a polygon. Regular polygons are the shapes that you probably think of when you think of shapes or polygons, because they look like they have the same angle, same size measurement. A square is a regular polygon, but a rectangle isn't, because a rectangle doesn't have the same side measurements. Here's a couple of types of names of other polygons. 5-sided is called a pentagon. 6-sided is called a hexagon. I always remember this because of the X in hexagon and the X in 6. Heptagon is a 7-sided. Octagon is an 8. If you don't know the name of a certain shape, for example, like a 10-sided shape, you could just say n-gon, or in this case, if it's 10 sides, let me just put it up here, 10 sides, you would say it's a 10-gon. So you could just use the number of sides and put gon at the end. You can see the name n-gon refers to a polygon that has n sides, so 15-gon has 15 sides. In example 1, we are telling whether the figure is a polygon. If it is a polygon, classify it and tell whether it's convex or concave. If not, explain why. Let's first talk about, is it a polygon? Part A, you should have said, yes, it's a polygon. B is not a polygon. Why is it not? Because of this. Because of the curve. Now, part A is a convex polygon because it doesn't go into the shape. A convex polygon is, let me just kind of draw that figure. It's kind of like the one you just saw up there, where a concave would have kind of jetted into itself. More like this. This is concave. I always remember this because it kind of looks like there's a cave inside of it. And this is a hexagon because there's 1, 2, 3, 4, 5, 6. B is no, it's not a polygon, and if it's not a polygon, it can't be convex or concave. And again, it's not made with only segments. Anytime you have a curve, it's not a polygon. Quadrilateral is any shape that has 4 sides. Some common quadrilaterals are a trapezoid. Trapezoid has one pair of parallel sides, and that's what these arrows represent. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So these two arrows means this side is parallel and this side is parallel. A rhombus is a parallelogram, so all sides they have a pair of parallel sides, but they also have 4 congruent sides, meaning this is all the same measurement. Okay, that's what congruent means, the same measurement. So it's kind of like a square on its side, where a parallelogram is more like a rectangle tilted. A rectangle is a parallelogram, but it has 4 right angles, where a square is a parallelogram, but has 4 right angles and 4 congruent sides. You will need to know the difference between these quadrilaterals. Let's classify these quadrilaterals. Part A, and when we classify it, you don't put quadrilateral. You try to find one of these 5 to represent the quadrilateral. So part A, you can see that the sides are not the same, but there's one pair of parallel sides. So which one said about one pair? Well, here's a trapezoid, exactly one pair of parallel sides. I would say this is a trapezoid. Part B, you have 2 pairs of parallel sides, and look at the measurements, 6, 6, 6, 6. So not only is it 2 pairs of parallel sides, which is any of these actually, these 4 down here, but you also have the same measurement on all sides. I would call this a rhombus. You could, putting parallelogram is correct, but it's not the correct answer, because when you classify, you want the best choice. So you want to say that this is a rhombus. Parallelogram will not be the right answer because it's not just a parallelogram. It's more specific than that. Fine, let's find an unknown angle measure of a quadrilateral. First of all, you need to understand that when you have a 4-sided figure, all the angles equal 360. Remember when we had a triangle, it was 180, now it's 360. So let's add up our 4 angles. So we have an x plus 5 plus 125 plus, what's this square? How many degrees? 90 degrees. Let's combine like terms. So these x's I can put together. X plus x is 2x. This 5 plus the 125 plus the 90 is 220. 2-step problem now. Let's get rid of the 220. Add the opposite of 220. You're left with 2x equals 140, and then divide by the coefficient. X equals 70. Now this just asks you to find the value of x. Sometimes you will have to plug the x back in. Let's try number 1 and number 2. Tell whether the figure is a polygon. If it is a polygon, classify it as convex or concave. Pause the video, try 1 and 2. Number 1 is yes, it's a polygon. And you should have said that it's a convex polygon. Also, you should have named the polygon. That's what it means when it said classify it. And there's 1, 2, 3, 4, 5 sides. Pentagon. Number 2 is no, it's not a polygon. Why? Because there's not line segments. This lesson is done.